Hello, this is the last uh, class that we talk about chapter 7, and it's Friday, and Monday we will talk about chapter 4. So as a last class on dimensional analysis, I'm going to solve two questions for you. It may take little, not the same as the other classes, maybe 1 hour, but I'm not going to start chapter 7 today. So maybe maybe longer if you have any questions, but mostly for me it takes 1 hour to solve these two questions. So question 1 is about comparing a model with a prototype and a real case, and we are going to do step-by-step analysis of Buckingham pi theorem, finding the pi terms, and then finding the required length or diameter and viscosity of the model. And finally, excuse me, finally finding the velocity scale. Okay. So let's read the question and decode it. The model is to be used to determine the velocity of a liquid. Okay. Determine the velocity of liquid. When you have this determination of a term or variable, it means that this is going to be your dependent value, right? It will help you later in finding and in selecting the variables. The second part is that it's passing through pipe connecting to pressurized tank 1 and 2. It shows here. You don't need the numbers right now. The model is to have the length scale of 1/4. So length scale is also given. This is the second one, which means for the prototype. Viscosity scale is also given. Okay. Right, as you assume the velocity of is a function. So as I mentioned before, most of the time the question give you the list of variables, right? Okay, so here is also given. Assume the velocity is a function of the pressure difference between the tanks, the pipe diameter, the pipe length, and viscosity. Okay, so these are also given. Okay, so let's summarize or decode from question. What we have. We have first, velocity is a dependent variable. Second, geometry model, geometry of the real over the geometry of prototype. Is 4. Why? Because it's mentioned here, lesser scale is 1/4 of the prototype. Absolutely, prototype is not going to be higher in the length of higher than the real one, but also it mentioned that it's 1/4 for lesser scale of prototype. So it means that geometry of the real case is 4 times of the prototype. What is the third one? The mu of prototype or model is 2 times of mu of real. This is given here. Viscosity twice of the prototype viscosity. Okay. Finally, The fourth thing that we know about it is the V will be a function of delta P, E, L, and mu. These are four things that we know from the question. Okay, so part A, finding the pi terms. For pi term means applying the pi theorem. We have steps. We are going to write the steps and do it one by one. So step one is already is done. List variables, right? So listing variables is easy because it's given in the question. F is delta P, P, L, and mu, right? This is a step one. For a step two is expression in form of FLT or MLT. So any variables that you have to write in the form. So let's do it. Also, these are in the book, and I will give you during the exam, I will give you a table. So you will have it. You have to just find it, decide that which method you are going to use, FLT or MLT system, and then write it. So V is L E minus 1, right? Delta P, I'm using the FLT method. That's easier for me. And most of the time it's easier. Is delta P, D is L is L, and finally mu is FTL minus 2. Okay, so this is a step 2. Step 3 is what? Is just doing math. Number of pi terms. How many we have? Okay, so we need two numbers here. First, what is the K? What is the K? K means number of variables, right? 1, 2, 3, 4, and 5. So K is going to be 5. The second one is R. How many reference units you have? You have FTL and just S, right? So 3. And using these two, K minus R is going to be 2. These are going to be your number of pi terms or dimensionless groups. Okay, so these are your dimensionless groups. And what else you know? You know that when you have two K minus R at the same time, you have two non-repeating variables and odd number of repeating variables. So you have to decide which one is your odd number of the set for repeating variables. Then whatever is left is going to be your non-repeating variable. Finally, totally you have 5 variables. So 3 of those going to be your repeating variables and 2 is going to be your non-repeating variables. So that's till now is step 3. So The only challenging part in pi theorem is step 4, deciding which one you have to select. Select repeating variables. Then whatever left is going to be your non-repeating variable. Okay, so let's list those. V, delta P, L, D, and mu. V is LT, routing the variable and the unit. LT minus 1 F, L minus 2, L, and F, T, L minus. Okay. So right now you have to decide which one you have to choose. Okay. At first, from the question, you know that the V is dependent. So for sure, this should be one of the non-repeating variables. This is for sure non-repeating variable, okay? And the second is that one of these two are the same, right? E and L are simple at first. So because they are simple, at least one of these should be selected. One of these two should be selected, but just one is enough because these two are going to be the same, right? But you want a set that cover all the variables and all the different reference units. So this should, one of these two should be selected. Okay, perfect. So if I list here, repeating variables and non-repeating variables. I know that for sure, V should be here, the non-repeating variables, and one of these two, for example, L or mu, I choose L. If you choose D, nothing, it's not wrong. Again, it's up to you, okay? But what else we need? Why we shouldn't, so that's the question. Can we choose FL or delta PL and D as our set? No, we cannot. Why? Because we have a unit of T, okay? And you need a set to cover all three reference units, right? So if you choose these three, then you cannot cancel out T here and here because these two are going to be your independent variables. Okay, that would be, that's not possible. The only way is that this is not good mathematically possible. You cannot do that, right? So choosing these three, delta P, L, and D, are not possible to be to solve. Okay, so you cannot find the Python because the T is function of V is a function, has a function of T, and you know that this is for sure one of your non-repeating variables, right? So just list those two here, and since you know that the L is here, and you just want to select one of these two, then mu and delta P going to be here. And another method to find out why mu should be selected, okay? The only term that has T as a unit is mu. And you know v is a dependent variable. So if I write the rationale behind that, v is a function of t, okay? And you need a repeating variable to cover t, okay? What is that repeating variable? It's going to be mu. So mu should be selected. Okay, perfect. You know, mu should be selected, but at the same time, mu is function of what? Function of t. I'm sorry, function of f. So you need to cancel out that. Okay, so for sure, delta p also should be selected, right? That's the question. It should be selected, it's better to be selected. Doesn't matter if you don't choose delta p as a repeating variable, okay? Then this is not repeating variable, and this tree could be selected as a repeating variable, right? So instead that you selected L, L, and FTL minus 2, then you have all three reference parameters, and these two going to be your non-repeating variables, right? And in your equation, you also, in your set, you have term with FTL, and the other terms also L, so it covers, okay? This is not wrong. Again, you can decide. That's the problem. We are engineers and we work on mathematics. We always think that, okay, any question should have a unique answer. It's not like this. That's why most of the students have problems, because it doesn't have a unique answer. The only thing that you have to be worried about, not that much. Again, if you choose a different number of variables, as long as that you're doing right mathematically, you have a PyTorch, and if the PyTorch are non-dimension or dimensionless, then you're good. If no one can deduct any point from you in exams, right? But we are not talking about just exams. We are talking about your research in future, or the work that you have in company when you have a new problem. Then what is your job in finding those Python? What is the reason for doing that? The reason for doing that is finding the Pythons that at least are known. You remember that we talk about different Pythons like Reynolds number? If that combination give you the Reynolds number, okay? For example, here, if you had rho and rho VD times mu, you have all terms needed for Reynolds number, okay? If Python, one of the Python or Reynolds number, it's better to select those parameters in a way to get that Reynolds number. Because, why? Because you can find thousands of experimental studies that done before, and you can compare yours in this question with them, because they are reporting the Reynolds number as a parameter that they are testing, okay? That's why these known parameters of non-dimensionalized parameters like Reynolds number, Weber number, and the rest are important. And it's better for you to decide, select a set to finally have those Pythons, right? But mathematically, again, there is not unique solution, but there is a better solution, okay? Step 4, we decided what is the repeating and non-repeating variables. So step 5, the rest is easy. Just what should I do? 4 Pythons and find exponents. Okay. So what is our pi1? Pi1, always pi1 use the non-repeating or dependent variables that the question gave you. So V comes to pi1, and the second one, third one, the rest that you decided to be in repeating variables come to the other pi term. That's better. Not again, there is not rule for it, but it's better to do that, to be consistent with like other books and maybe solutions, right? So pi1 is V as a non-repeating variables, then delta P to the power of A, L to the power of B, and mu to the power of C. Again, the sequence also doesn't matter as long as that you're doing right. So F to the power of 0 to and L to the power of 0. Okay, these are should be the same. LT minus 1 for delta P. I'm sorry, for V. And then for delta P is F L minus 2 to the power of A, L for L to the power of B, and Ft L minus 2 to the power of C. For pi2, we have D delta PA, L to the power of B, and mu to the power of C. You can write primes here, okay? Just because easier to find or follow the solution. F to the power of 0. This is going to be L to the power of A. Oh, that's for D. Nothing for the exponent. And then the same as above, but A prime, B prime, and FTL minus 2 to the power of C prime. Okay, this is your equation 1, and this is your equation 2. I'm going to start with equation 2. There is a reason behind it. Absolutely, you can create 3 equations FLT, then find the unknowns here, right? It's totally okay. Going to be time consuming sometimes, but that's not right. But I'm going to give you a pre-understanding that what would be the answer finally, okay? And most of the time, you will see in solutions that no one write anything but find the final answer. That's the reason, okay? So there are some rationale that why we know we don't need system of equation here. Equations for pi2. Why we don't? First, you see that the only term that gives you the constant numbers is L, right? When you only have one L here, then you don't have any F here in your non-repeating variables, right? So as a rationale, C prime should be 0 because the only term that has T, right? You don't have any other term that has T, okay? So when you don't have it, if you put the C prime as a 1, 2, or minus 1 on whatever, any number except 0, then you have T to the power of that, right? But you also should have this equation that T is to the power of 0. So one of these should be a number that cancel out C prime, or t to the power of c prime that you can calculate it, then it's not possible mathematically. The only way, because the only term that you have is here, the only term with the unique reference is this one, okay? C prime has t, okay? And is the only one that has. So C prime should be 0, okay? By considering that C1 is 0, then you don't have this term, right? When you don't have this term, again, the only term that has F is the second term with A prime. Again, with the same rationale, now the second term should be 0. The A prime should be 0 because this is the only term that has F. Now you cancel out, you find two equations, two exponents without doing that. Without solving a system of equations, writing the equations, and just with the rationale behind that. Okay, so A prime also should be 0. Why? Because now is the only term with F. So why should I'm doing that? Actually, I could make it easier. Just write the equation and find the answer. Yes. But understanding this rationale gives you a hint before solving an equation. I was grader for most of the courses. I was grading the midterm final, and I saw many differences and lots of students that the lose point because of using calculator or solving the system of equations, and everything was correct. Everything was correct in the solution and the writing the answer, except using the calculator, or maybe because of the by mistake added the numbers or couldn't solve the system of equation, which is the most easier thing in your homeworks and exam. So that's why I'm giving you this idea that when you know what are you doing right now in solving the equation, and you can even solve the equation with some pre-understanding, then also you can check your answer, okay? These are helpful for you. But again, if you write the equations and system of equation, and then without understanding that, hey, what will be the final answer? Yeah, that's still true, okay? So we find that A prime is equal to C prime equal to 0, right? From these two, then the only term, the only equation that you need, because you only have B prime as a unknown. So the only equation is for L, 1 plus A prime equal to 0, then, I'm sorry, it's B prime. You're talking about equation 2. B prime equal to 0, then B prime is minus. Perfect. The others are 0. So let's make the pi term. Pi term for this one is E over L, or L over D. Doesn't change anything. Doesn't matter that you find B prime equal to -1 because it's 9-dimensional term, or you can just decide to be D over L or L over D. It means that possible that to choose L instead of D as your independent variable and dependent variables. That doesn't change anything. So you can decide which one you want to write. But both of them are correct. That's for pi 2. Okay. So now it's time for finding pi 1. Solve for pi 1. Okay. I'll put it here to write the equation. Okay. So for pi1, you need 3 equations, F, L, and T. For F, answer absolutely should be 0. F is, the first term is 0. The second term has F as A plus A plus the B1 is 0. And the last one is C equal to 0. For L, the first one is 1 minus 2A plus B minus 2C equal to 0. For T is minus 1, nothing, nothing. And the last one is C, minus 1 plus 0 plus 0 plus C equal to 0. From here, you will have C equal to 1, right? And if you bring it here, replace here, then A is minus, right? Now bring it here and replace these two. In the second, one here and one here. These two in equation 2 give you minus 1, 1 plus 2 plus B minus 2 equal to 0, then B is going to be minus 1. You have A, B, and C. Now the second part will be greater. Pi1 is V mu delta P. Okay, that's only a checking. This is not a step in pi theorem, but checking is also helpful when you don't know that you did the calculation correct or not. So check the pi terms units and make sure that they are unitless, okay? Check the dimensions of the pi terms of the groups. Pi1 is delta PL. The units are LT minus 1 times mu is FT L minus 2. Delta P is FL minus 2. And this is L. If you write it LT minus 1 times FT L minus 2 times F minus 1, L plus 2 times L minus 1. Okay, so this T is going to be canceled out. Let's write it here. This is minus 1 and this is plus 1. So these two are canceled out. The second one is 1 is minus 2 is plus 2 is minus 1. Minus 1 plus 2 minus 2 and 1. These are going to cancel out. And also F is cancelled out with this. Okay, so these unitless. Pi2 is P over L, it's easy, L over L going to be L to the power of 1, so L to the power of 1 times L to the power minus 1 is going to be L to the power of 0. This is also unitless. The last step and the most easiest one, step 6. Express the final equation. The pi1 that has your dependent variables, that's the most important one that you are going to, that the question asks you as a function of the second pi term. This is expression for final. Okay, that's step 1. I'm sorry, step 1 means the A. Let's read part of the question and see what is the second part. The second part asks you that the required length, diameter, and viscosity. Okay, the required length, diameter, viscosity. We are talking about the prototype, not talking about the real one, right? Because the real one is real one. You can see and measure. But what is the required length when you're going to mimic the situation and check the results, right? You're doing the experiment on prototype. So what is the, at first, it asks you what is the D, that's the diameter, mu, and L of your model. These are asked. Okay. So we have a geometry scale from the question, and that was geometry of the model is 1/4 of the geometry of the real case. So L of M, this M is model, is the real L over 4. Okay. Here you have mu, D, and L as your given in the question. Okay. So mu, D, and L are given, and the L is 4 inch. Then LM is 4 inch over 4 is 1. What is the mu of the model? The mu of the model, it mentioned that is 2 times of mu of the real one. Yes, it's twice. So mu of the model is also using the mu that are given here, 2.2 over the feet squared is mu m 0.2 feet squared times 2. That's your final answer for mu of the model. And what is the D of model? Is again, geometry scale is D over 4. D of the model is given, D of the real case is given 0.1 inches, and over 4 give you 0.25 inches. Okay, so part B is easy, just applying that, okay? In any questions in this chapter, you may ask 3 jobs. First, finding the pi, applying the pi theorem, and finding the pi terms. So we did in part A. The second is that it gives you a relation between those two, maybe the diameter or maybe the mu and maybe the fluid that you use, and then ask you what would be your prototype size, what would be your prototype mu, and the rest, okay? And the third part is here. Now find another ratio, okay? So this is the third thing that they ask you. You don't know what is the velocity in real one, and you also don't know what is the velocity in the prototype because you didn't do experiment, right? But you can find the ratio. How? Using the Pythons. This is also given in the question that here, if the pressures are the same for model and prototype, using this information, then you can find. So part C, it is given that delta P of the model is equal to delta P, right? Delta P of the case. And it asks you what is the VM over V. Again, you don't know what is VM because you didn't start experiment. You're doing your setup, your experiment, right? Okay. And also you don't know what is the V. Because if you know that what is the V, then you was happy. You know that, hey, V can be calculated. So what I'm doing experiment, you have equation for it, but you don't have it. You want to find the nature of that equation. So, but we know that the pi one, the model pi one should be equal to pi one in the real case, and pi m2 should be equal to pi 2. These two should be valid. That's the nature of the Python. That's one of the results in Python. So what is, if you use the pi 1, that VM is part of it, because pi 2 is d over d. Doesn't work right now. VM mu m over delta PM LM is equal to V mu delta P. This is for real case, right? It's also given that these two delta P are equal, so it can be canceled out. Then you can bring V in this denominator, then Vm over V, this could be equal to mu over mu m times Lm over L coming up. Then Vm over V is equal to, you found that the mu of the model is given, that mu of the model is 2 times of this mu, right? So this would be 1 over 2. And you know that the model is in 1/4 of the real case, okay? So this is all going to be 1 over 4. Then the answer would be 1.1 over 8 or 25. That's the ratio. That's your velocity ratio or scale. That's it. Any question?
Do you mind just putting part B up for like 1 second? I just want to take a picture quick.
I will upload those.
Okay, great. Thank you.
All notes that even the question that I solved during the class, all uploaded. Maybe sometimes you download the file, but I changed that because after class by class, I will merge those PDF files, or sometimes I'm just uploading those separately. But all notes in the class are available in Jubilee. And these are also Would-Be. Any other question related to the concept? Okay. So we are done with this part. Okay. Question 2. Given that a golf ball is to be tested by using a model wind tunnel. Okay. I had an advisor that he was old. He is retired. He got his PhD in Berkeley, I guess, in 1970 or 75. And his PhD project was about exactly the same. The golf ball and testing the finding was aerodynamic and aerospace engineering. And his project was exactly doing this experiment. And it's not something that's just given. These are based on real experiment that is done. So a golf ball is to be tested by using a model in a wind tunnel. Okay, the drag force on the golf ball, FD, is dependent. So first part is here. 1, FD is dependent. Second, he also given that is a function of listed variables is also given. So list of variables FT should be a function of mu, rho, d is the ball diameter, and d sample length, depth that's on the golf ball, v velocity, and omega, which is the angular speed. If you don't know, the unit for omega is RPM, which is round per minute, or 1/t, or 1/second. This is the unit for omega. A, determine the set of suitable dimensionless parameter for simulation, right? So step 1. Apply the pattern. Step 1. List variables. FD is function of mu, rho, d, v, and omega. Step 2. Expression, right? You have to express those as in FLT or MLT system. So I choose to use FLT system method or system. Then FD, the drag is going to be F. Mu is FTL minus 2. Rho is FT2L minus 4. D is L. D is L. V is LT minus 1. And omega is E minus 1. Okay, these are my listed variables. Step 3. Calculation. Okay. So K, R, and K minus R. K is 1, 2, 3, 4, 5, 6, and 7. Okay. So K is 7. R is listed of reference units 1, 2, and 3. Then using these two, K minus R would be 4. Number of the groups that you need. 1 is 4 pi terms. 4 non-repeating variables needed for this pi terms. And finally, 3 repeating variables. These are our conclusions, okay? So Step 4. Make your set. To do this, we'll write this fd mu rho d d v and omega. This is f t l minus 2 t squared l minus 4 l t minus 1 and t minus 1. Okay. So this is absolutely, if you write here, what is our repeating variables? This is for sure should be used because the question told you that is a dependent variable, right? Since you have F means the drag force, that is unit of F, as one of your dependent variables. So it should be canceled out with one of these units, right? That you select as a repeating variable. So absolutely one of these two should be selected. Okay. So rho or mu should be selected. Can be both of them, but yeah, it can be, it should be one of these two. And these two are the simple ones. So one of these two. And I guess one of these two are good. It could be a good set, right? And one from here, one from here, and one from here, right? So it's again up to you that which one you choose. And if you choose a different one with even solutions, it's not wrong. Again, it's not wrong. But sometimes, because those are not unique, the question told you that, can you find the Reynolds number here? Then that would be different. Because it asks you that, hey, can you find a specific item? Then you can say that, hey, I have to choose a set that finally give me a unique answer that the question asks, right? So in this type, these are going to be different. But right now, you are free to choose whatever you want. Because it's your question, it's your experiment, and it's up to which one to choose. Step 5. Items. And finding exponents. Okay, so let's write for pi 1. For pi 1, we have fd. Okay, so let me just write here that my repeating variables is, I decide to choose rho from between rho and mu, and between the two D's, D and capital D and lower D, I choose the D of the ball because it's much more important than the lower D, which is for, which was for, is for the dumbbell depth. I don't know what is it exactly, but the D of the ball is mostly important. Also velocity, instead of using omega. These are much more important than the others, right? For me, my view. So again, I choose it. So rho to the power of A, D to the power of B, and V to the power of C. Okay. Now these are just solutions. F, L, t all to the power of 0, then f times f t squared L minus 4 to the power of a, L to the power of b, and LT minus 1 to the power of c. So this set has L, has T, and has F. It covers all the reference units and also most of the important ones, right? Most general variables that could be said, you can say that most of the questions in fluid mechanics are dependent to the length or characteristic length of that material, like pipe diameter, pipe length, or for ball is a diameter of the ball. And the density of the fluid is one of the most important. Absolutely, mu is also important, but most of the time, rho is like mass. Most in any equation in the solid mechanics, you need mass and also velocity. So these three are most general one. That's why we choose. Okay, so reply for F. F is 1 plus A doesn't have 0 plus 0 equal to 0. For L, we have 0 minus 4A plus B plus C equal to 0. And for T, we have 0, we have 2A, 0, and minus 1. Minus C equal to 0. Okay. Here I can find that A is minus 1. Then I can bring it here and replace in this one. When A is minus 1, then C is going to be 2A, so C is minus 2. Okay, now I can break this one. And replace. These two. If I replace that, I have 4 minus 1 times minus 4, B plus B minus 2 equal to 0, then B is minus 2. What is the pi term? So pi 1 is FD. All has to be on the denominator. So rho A is 1, T squared, V squared. Pi 2 is the second variable is mu. We had FD mu rho d d d VL V omega. So we choose rho d and V. Then the repeating variables, the non-repeating variables FT, we found the pi term for that. Now mu, then d, and finally omega. Mu rho to the power of A, d to the power of B, and V to the power of C. Okay. Now FLT or LT, sorry, FTL minus 2 for mu, then FT to L minus 4 to the power of B, oops, A, L to the power of B, and LT minus 1 to the power of C. For F, we have 1 here, plus a plus 0 and 0 equal to 0. Again, a would be minus 1. For L, we have minus 2 minus 4a plus b plus c equal to 0. And for T, we have 1 plus 2a plus 0 minus c equal to 0. Minus c and s, okay? Then you have to replace here. And minus 1, minus 2, plus 1, minus 1, c is going to be 1. It's going to be minus 1. Minus 2, minus 1, c is going to be minus 1, right? So from here also we have minus 2 plus 4 plus b minus 1 equal to 0. Then b is also minus 1. Okay, so what is pi 2? Pi 2 is mu on top, and all comes with the power of 1, rho v d. And also you can write is as rho v d over mu is your Reynolds number. Pi 3, d rho a, d b, v c. Okay, so FLT is equal to L ft squared, L minus 4 to the power of a, L to the power of b, and LT minus 1 to the power of c. Again, using rational, you can solve it. You can do it at home by making the sum of equations, but also you can see the same answer, okay? The only term that has f is here, right? If you want to find this as FLT all to the power of 0, then this should be 0. A should be 0 here. When L is 0, this term is A is 0, then you don't have it, right? When you don't have it, again, the only term with T now is here. So this is going to be also 0. Okay, these two are 0. The only thing is L, 1 plus A, B equal to 0, then B is going to be minus 1. Then your pi 3 is D over D or D over D. Both of them are correct. For pi 4, omega, rho to the power of A, D to the power of B, and V to the power of C. FLT all 0 equal to T minus 1, FT squared, L minus 4 to the power of A, L to the power of B, and LT minus 1 to the power of C. Okay? So again, the only term with F, this should be 0. Right? This should be 0, but now you have a term with L, you have a term with L and T, and you have T. Then you cannot say that all A, B, and C should be 0. The only thing that you know that you don't need to calculate A, right? So just two equations are enough. For L, you have 0 plus B plus C equal to 0, okay? Which is B equal to minus C. And for T, you have minus 1, and you have 0 plus C equal to 0. Then C is 1. C is 1, and B is minus. Oops, made a mistake here. C times minus 1 for t. Then only thing is that this is minus 1 and this is plus. And pi 4 is omega, which is omega. C is minus 1, so V comes at the denominator, and D comes. This is your part 4. Step 6, expression. Final form, right? So pi 1 is should be a function of pi 2, pi 3, and pi 4. Okay, so pi 1 is FD rho V squared D squared is equal to F rho V D over mu. I use the Reynolds part shape O and D over D omega D over V. That's your final form. What was the second part of the question? We are done with part A. We find the final equation, find everything here. But a model of the golf ball is to be tested in a wind tunnel where the velocity scale is one cell, right? Absolutely, the wind tunnel you are choosing to have a lower wind velocity. It's that way you can test it. So in a model versus the real case, the velocity are 1/3, and then the fluid property are the same. So mu and rho are the same in both of them. So you use the same fluid and same temperature. It's given that professional golfer can hit a golf ball with a 1.68 inches in diameter and create an angular speed of 9,000 RPM, right? It's given you that what is the real can be done. How they found it, I don't know, don't care. But how we can, how they found that, we don't know, but it's given, okay? So if I summarize here, part B, V of the model is V of the real is 1/3, okay? And also it's given that mu of the model is mu of the real, and mu rho of the model, so the fluid properties are the same. And this rho is also equal to rho. What else is given that the D of the real is 1.68 inches, and then omega of the real is would be 9,000 RP. What is asked? Find the D of model and omega of model. How we can find it using the pi terms, okay? Just select the pi terms that have D, omega, and V, because these are given, right? So one of those are Reynolds. That's why Reynolds is very important. Okay, so rho VD of mu in model should be equal in rho VD of the real case, okay? But we know that these two are equal, it's given, and also rho's are equal, okay, given in the question that the fluid properties are the same. So Vm dm in the model should be equal to V or dr of the real case, okay? Because I have V model over V real, then I can bring the VR here, and let's write Vm over VR is equal to dr over dm. And we know the answer would be 1/3, right? But it's equal to this. Okay, then dm is 3 times dr. dm is asked to find it, and dr is 1.68 inches. So dm is that's dm. Okay, what's next? I ask you to find the omega. For the omega, let's use pi4. Omega d over v. Okay, and is omega m dm over vm should be equal to omega dr r and vr. Okay, so first, what's asked? Find the omega m. So keep omega m in one side and bring the others on the other side. So omega r, bring dm here, dr over dm, and vm on top times vm over vr. Okay, so vm over vr, you know, it's 1/3. dr over dm, dr over dm is also 1/3. And what is omega r? It's 9,000. So omega m is 1,000 RPM. That's it. Any question? That's enough for today. Next week we are going to talk about chapter 4. I'm not sure that chapter 5 is part of your midterm exam, but chapter 4 would be. Until that time, you will have a necessary homework, required homework that is handed to you, and you also give the solution and your final score for that. So chapter 1, 2, 3, dimensional analysis, chapter 7 plus chapter 4 for sure are be part of your midterm exam. But I have to think about chapter 5. I'm not sure that we can manage our time to have chapter 5 or not. If not, it will be covered in the final exam. If you don't have any question, you are free to go. You can stop recording.